Assalamualaikum. So this is for course BMMA 3533 Vehicle Dynamics for assignment Vehicle Rollover, which is lightweight. This is presented by 3BMMA S11 Group C. Our instructor is Dr. Nurashid bin Mat Nuri. As you can see, the example of rollover crashes beside. Then we have our group member detail. First is Muhammad Syafiq bin Abdul Talib, Muhammad Aiman Najmi bin Muhammad Sabri, Muhammad Badrin bin Syam Suhaimi, Muhammad Arya Afnan bin Abdul Wahid, and Muhammad bin Abdul Hamid. Then we go to the introduction.
Okay, for the introduction, a rollover is a type of vehicle crash in which a vehicle tips over onto its side or roof. Rollover have a higher fatality rate than other types of vehicle collision. Vehicle rollover are divided into two categories, which are tripped and are untripped. The tripped rollover are caused by force from an external object. Untripped rollover are the result of steering input, speed, and friction with the ground. Firstly, untripped rollover happen when the vehicle is destabilized by cornering force. Okay, for the trip rollover, it happen when a vehicle is sliding sideways and the tire hit a curb, dig into soft ground, or experience another incident that cause a sudden increase in lateral force.
Okay, before we move further, let me summarize this. The first article, the title is Mass Data Measurement, Approximation and Influence of Vehicle Stability for Ultra-Light Human-Powered Vehicle. That was published on 13 June 2021. Next, the article titled Heterogeneous Impact of Gender Interfacted Contributing Factor on Driver Injury Severities in Single Vehicle Rollover Crash. It was published on 27 May 2016. Next, factor affecting injury severity of single vehicle rollover crash in the United States. That was published on 16 January 2020. The death control strategy of vehicle anti-rollover, considering driver characteristics. It was published on 23 July 2020. And the last article is about research on electric vehicle rollover prevention system based on motor speed control. That was published on 18 October 2021.
Okay, for the article 1, which is mass data measurement, approximation, and influence on vehicle stability for ultra-light human-powered vehicle. Okay, for the methodology, we have four. The first one is center of gravity measurement. The longitudinal and lateral center of gravity position were calculated by measuring all of the wheel load in the horizontal position. Then, moment of inertia measurement. The yaw moment of inertia, which is required for most vehicle lateral dynamic model, such as single track model, was the focus of the investigation into moment of inertia. Next, vehicle lateral and rollover stability. The center of gravity of the vehicle has a significant impact on its self-steering behavior, which is oversteering and understeering. Vehicle and driver data. It depending on the duration of vehicle availability and the availability of the test individuals measurement of the various vehicle were taken at different time and with a larger or lesser number of different drivers. Okay, for the result, uh, longitudinal center of gravity and lateral stability. Uh, The oversteering vehicle might have become unstable above the critical speed. Okay, next, center of gravity, high and rollover stability. The center of gravity should be as low as feasible to create a small frontal area for aerodynamic and excellent rollover stability. Next, inertia measurement. A significant mass concentration at the COG was indicated by a tiny value. The fourth one, initial estimation. The collected initial data was utilized to develop approximate for calculation the moment of inertia. Last but not least, stepwise regression, a method for defining approximation equation that is algorithm variable that do not add significantly to the correctness of the description are deleted from a basic model that comprises variable and interaction up to a particular degree. Okay, next.
Okay, next Article 2, heterogeneous impacts of gender interpreted contributing factors on driver injury severities in single vehicle rollover crash. For the methodology, first mixed logic model. Each logic models explore the effect of numerous environmental factors as well as driver characteristics on driver injury severity in rollover collision. Second, model specification test. The difference in parameter numbers between the two models equals the degree of freedom for this distribution. The third, the temporary transferability test. To see if the mixed logic model can be transferred over the years, a temporary transferability test is performed. Okay, for the result, first, the probability of human drivers sustaining a non-incapacitating injury is higher. The disparity could be due to an observed factor that are not accounted for this model. Second, the female drivers are more likely to sustain no injuries when the roads are unpaved. They are likely than male drivers to sustain serious injury. Due to the pure driving environment and reduced speed limit settings, female drivers may drive more cautiously on gravel roads. Next, the driver will be less cautious with higher speeds on dry road surface than the other unfavorable surface condition. This means that while the road surface is dry, most drivers are more likely to experience serious injuries in rollover crash than when it is wet. Lastly, alcohol influence and left turn are significantly influence driver severities in single vehicle rollover crash. This could be due to the fact that when compared to driving straight, drivers slow down when turning left to prevent hitting vehicles coming from other direction and lowering the risk of injury. Next.
So for the Article 3, factor affecting injury severity of single vehicle rollover crashes in the United States. For the methodology, data sources and preparation, the fatality analysis reporting system, which is a nationwide census of the yearly data regarding fatal injury experienced in a road incident that happened on public highway, was used to extract single vehicle rollover crash data. Rollover collision can caused by a vehicle or triggered by an object. Then we have a model development. Under this assumption, data estimation are constant across all severity level. To explain the diversity in crash injury severity, researchers look at a number of factors including the crash, the roadway, the environment, and the driver and the vehicle. So for the result, the rate of partial or complete ejection during a rollover is reduced due to the seat belt. In a rollover incident, seat belt use was found seat belt use to reduce the probability of partial or complete ejection during the rollover because there are links between seatbelt use and ejection. As the result, the chances of suffering major injury and the from the ground or being crushed during the rollover. The risk of fatal injury for ejected rise as it rise. The other in the risk of fatal ejection is substantially higher than the risk of serious injury at all speed restriction. then this are more likely to be associated with a serious injury. This conclusion could explain why there were more quarter turn after the rollover start. This finding support program that urge driver to observe speed restriction through education and enforcement. Lastly, is vehicle age significantly influence injury severity in rollover crash. When we compare newer automobile vehicle model built for 2000 years were more likely to result in fatal injury. All from me. Next.
Okay, for the next article, Article 4, about control strategy of vehicle anti-rollover considering driver characteristics. The first methodology is critical safety supervision area. The primary goal of the crucial safety supervision area is to determine the relationship between vehicle velocity and part intervention while taking into account the maximum angle and various driving rollover threshold. Next, decision control mode. The six decision-making modes are defined in this part. They serve as the foundation for the weight distribution between executive control based on active steering and active braking of the driver. The active steering control design. The active steering control design goes as follows. When the driver deviates from planned course, the vehicle is given external front wheel angle to help driver better track the expected trajectory. Lastly, active brake control design based on direct structure feedback. At this point, active braking must be used to reduce vehicle velocity. This must then be paired with active steering control to monitor the path and avoid a rollover accident. For the result, the first is analysis of anti-rollover performance. The anti-rollover performance of the vehicle under individual control and the cooperative control reside in this study analyzed in this part using PLTR and roll angle rate based diagram. Next, analysis of path tracking performance. This section examines the route tracking performance of vehicle under individual and cooperative control using lateral displacement, lateral displacement error, and phase diagram of yaw angle and yaw rate. Lastly, analysis of driving operation load. This section examines the driving operation load under individual and cooperative management of the driver using front wheel angle and wheel cylinder pressure. Okay, next.
Okay, for Article 5, research on electric vehicle rollover prevention system based on motor speed control. The first methodology, roll dynamic model, a 3 degree of freedom rollover dynamics model of the electric vehicle with lateral, transverse, and lateral tendencies was designed to provide active rollover control of the vehicle. The second is vehicle rollover evaluation indicator. In general, lateral acceleration maximum, lateral tight angle, and lateral load transfer rate are the three most prevalent evaluation indication of vehicle rollover. This is LTR. The third is attitude solving. In rollover control, the attitude solution has an initial angle equation and update algorithm in which the original attitude angle is the first obtained. The next is driving motor control strategy based anti-rollover. That is because the longitudinal travel speed and lateral travel acceleration as well as the yaw rates determine the lateral acceleration of the vehicle center of mass, reducing the longitudinal travel speed of the vehicle and can directly reduce the lateral acceleration. The next is circuit design. The chief utilities in this paper's development board was from ST. And the last is the brushless RC4WD vehicle capable of speed between 50 and 70 km per hour was chosen for this study. Okay, for the result, the active control system start to slow down the motor. That is the first. The active control mechanism slow the motor down from 47 km per hour to only 10 km per hour.
and the LTR value is reduced to a safe level. The second is the actual roll angle and the LTR change are different due to interference. The changing trend in the overall curve is the same, which has no influence on the analysis of the test result. The last is can prevent the occurrence of vehicle rollover. When the vehicle is in a rollover dangerous driving situation, the control system reacts swiftly and control the motor speed down in time, lowering the vehicle speed and lowering the side tilt angle and LTR value proportionally before gradually restoring the vehicle to a smooth driving state. Thank you.
Okay, for the conclusion. In conclusion, individuals are increasingly demanding vehicle environmental preservation, energy conservation, safety and comfort as technology advances. However, because it is impossible to change the mechanical structure of a car to drastically improve its quality, automotive electronics technology has become the current automotive trend. There are certain ways to avoid vehicle rollover, such as avoid situations that could cause you to lose control of your vehicle, avoid steering in panic manner, tires should be properly maintained and replaced as necessary, and make sure cars are appropriately loaded. Okay, that's all from us. Thank you.
Thank you.